Greetings, Algebra 2. This is a plan for the week of February 27th through March 3rd. Since we have an odd schedule this week, I thought I'd give you an update on what we expect to get done this week. We're going to be using a blended model. That is, you're going to be doing some things in class and also some things out of class, since we're missing class time with the ACT and the work key schedule this week. So here's kind of a quick overview of where we've been and where we're headed. We do need to be sure that we get through the law of sines and the law of cosines this week. First of all, we've used the Pythagorean theorem in the past to solve for missing sides of triangles. And to do that, notice I've put SSS here. That's if we have an unknown and other values on the sides. So you might remember we used this when we proved two triangles were congruent to one another. So this is kind of where we would have numbers, and this indicates where and when we would use the Pythagorean theorem to find the answer. We also learned about sine, cosine, and tangent. We re-entered that information and expanded things to using secant, cosecant, and cotangent. And here, if we have numbers or unknowns in positions like these, for example, angle, angle, side, or angle, side, angle. This one here happens to be angle, side, angle positioning. We can solve for x using sine, cos, or tan. If we then alternatively happen to have angle, angle, side labeling, that is possibly a number here, angle, angle, side, we can solve for other missing unknowns as well. So we have used sine, cos, and tan already. The third thing we worked with were special patterns with 45, 45, 90, and we found that these two side lengths, whatever they happen to be, and we can find the missing hypotenuse by simply multiplying that side length by the square root of 2. So for some quick practice, find the value of x in each triangle. You do not need to use sine, cos, tan, or Pythagoras to solve these. These should be solved on site. Please pause the video and try to solve these on your own. So that quick review of what we should be able to handle with 45, 45, 90s. Next, of course, we talk about the special patterns involved in a 30, 60, 90 triangle. Shortest side and hypotenuse are half and double of one another, and the medium length side is the short side length times the square root of 3. Again, some quick practice for you to find values of different sides just on site. You can pause the video, try them, and then come back and check out your answers. No real tricks here. We have had other practice over the weekend. We hope this has been enough for you. So now we proceed out of the realm of right triangles. Can we solve acute triangles? Can we solve obtuse triangles? And the two methods we've had were Pythagorean theorem and trigonometry. These cannot be solved using sine, cos, and tan. But there are some other laws that have been discovered that we can apply. These are called the law of sines and the law of cosines. These are the only two we need. We can solve any other oblique triangle. That's a fancy term for non-right triangles, including both acute and obtuse. We do not need the law of tangents. It's something we do not want to mess with at this point. Law of sines and law of cosines will allow us to solve for other triangles, including, when we say solve triangles, of course, we mean find all the angles, find all the sides. Monday this week, we do see all of our classes, so we will talk about the law of sines and give you some practice on that first day. Law of cosines, if we do not meet, if we're gone Thursday, we should be sure that we have a look at the videos. There are video supplements out there on Blackboard 9 under 2.4 and 2.5. And there are some examples. I will also make and explain everything video for the notes. We will not get to the law of cosines portion. We will do the law of sines on Monday. Thanks. Have a great week. Good luck on your ACTs.